Okay, so now we're going to get into the mechanics of how to do long division. We started with a fraction 1/5, and we want to turn it into a decimal. So 5 goes into 1, and we creatively turned 1 into its equivalent, which was 1.00. You can add as many zeros as you want. So when you do that, just remember that everything needs to be really lined up. Okay, so at the end of the day, when you look at your long division problem, the numbers should be directly over each other. The decimal point should be directly over each other. So it's really important, I think, to when you're beginning to do long division and learning how to do the procedures, that you use graphing paper. Graphing paper has these squares, these little squares, and they're aligned perfectly above each other. And so it's really easy to make these columns when you have them already set out on the page. So graphing paper will have everything really nicely laid out in order, so you can very easily see, I'm going to put the decimal point here and then the decimal point right up there. See how easy it is to follow that line? 5 goes into 1 0 times, and then you can also add zeros on after the decimal point. Okay, so when you start putting the numbers up here, you see how perfectly in a line they all are. It's much more difficult to do it on a blank surface, but if you're using graphing paper, I think that's a fantastic way to do it. Don't be shy about asking for a graphing paper, a scratch paper during your quiz and tests. Is going to be a big help. Okay, so again, what we're going to do is first, if we need to, and let's just use another one. Let's say 2/3. Let's use a new fraction here. Okay, so 3 is going to go into 2. But just like 1/5, where 1 is smaller than 5, here 2 is smaller than 3. So we're going to wind up with not a whole grouping, because there just isn't enough of this numerator to go around. Okay, so this is the procedure that we are always going to be doing after you set the problem up like this. Once you have gotten your numbers all set, you're going to have to put a decimal point at the end of this number. If this was like 285, you would, if this was 285, you would put the decimal point there. Wherever the number happens to stop. Here, since we're just dealing with 2, the number stops there. Also remember that 2 can be turned into 2.000, as many as you want. Let's just add 2 for starters. If you want to add 3 or more, feel free to. So that's after you put the decimal point, you put a couple zeros. Then, after that, the decimal point, and again, this is where those columns of graphing paper would really help out. You're going to put the decimal point copied right above itself. Okay, so before you even start doing the problem of dividing, you're going to make a couple things before you even do it. You're going to put in your decimal point in the copy, and then you're going to add a couple zeros for good measure. That's before you start anything. Okay, now we are going to start this process of repetitive multiplication and division. So this is a process. So you're going to be dividing and then you're going to be multiplying and then multiplying, subtracting until you get to the end of the problem. You're just going to do this over and over and over again. And it's actually called an algorithm, but you don't need to know that word. It just means a process that you do over and over and over again, which, by the way, computers are really good at. So that's why computers are great at doing long division, because it's just a repetitive process over and over. So if we don't have a calculator, which you won't in 7th grade on your tests, this is how you do it by hand. So how many 3s can go into 2? There aren't any. So you're going to put a 0 here. Okay? Now this is the first time that you're going to do some multiplication. We're going to do 0 times 3, okay? 0 times anything is 0. You put that product right here, and then you subtract it from that number, okay? So you can put a little multiplication sign there to remind yourself, and a little multiplication sign right here and a little subtraction sign right here, if that helps. Okay, so multiplication there, and then subtraction here, and then you bring down and you get a 2. Okay, so this is an important process. I know that you could just start out with 0 point and then just go on, because you can see that 3 doesn't go into 2 any whole amount of times, but it really is important to start this process off here so you get the whole thing. It's kind of like knitting, actually. If you don't knit the first one correctly and you keep going on, then it's going to throw everything off. So you want to make sure that you're doing all of the stitches correctly so you don't need to go back and pull them out. Okay, so we've done this first stitch, you could say. Okay, now, and this is why having graphing paper is very helpful, you're going to draw an arrow down from the 0. And I even if you use graphing paper, still draw the arrow. Even to this day, when I do long division, I draw my arrows. Okay, so please do that. It really keeps things in line. So now we're going to do this. 3 goes into 20 how many times? Okay, so this is sort of the equivalent that 3 doesn't go into 2 any, but 3 can go into 20 sort of by recharacterizing what we're doing. Remember, 5 didn't go into 1, okay, but 5 went into 10 dimes. So that's basically the equivalent of what we're doing, okay? And that is also, I see students try to bring down this decimal point. Do not bring down the decimal point. Just like, do you see how the decimal point here was not brought over to here? It's because we're recharacterizing this as $1 to 10 dimes, okay? So 5 can actually go into 10 dimes. If we brought the decimal point over here, we'd be stuck in the same place. And plus, $1 does not equal 1 dime. $1 equals 10 dimes. That's the beauty of the system, that the number is going to get larger here so that this divisor will be able to go into it, okay? So while you copy the decimal point up like this, do not drop it down. The decimal point, you will not find any decimal points below here because we're trying to get larger numbers that we can divide into, okay? Just like we turned the 1 into 100 cents. 3 goes into 20, 6 times. This is where knowing your multiplication tables really is important. So please know your multiplication tables up through 10 times 10 because it will really help you along in this process and smooth it out. Okay, so 6 times 3 I know is 18, which is as close as we can get to 20 without going over. Okay, so we've got 2 here, and then we'll bring down the 0, and then 3 goes into 20, again, 6 times. All right, 6 times 3 is 18. Wait a second, I see that I keep getting 2's, and we're going to add another 0 here. Again, you can add as many zeros as you want. Okay, and do you see that I'm still going to get 20 at the end? Do you see that basically I could do this forever, and I'm just going to keep getting 6's like this? Okay, so once you see that this is what's going to be happening, once you see the writing on the wall, so to speak, literally, after a couple of these, you can write dot, 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 and know that it goes for that same number and it repeats forever. Okay? So if you're going to turn 2/3 into a decimal, it would be 0.666. 3 6's is enough, and then to see the pattern, and then do dot, dot, dot. And so you have successfully turned a fraction into a decimal, in this case, a repeating decimal. But sometimes the decimals will actually terminate or end, and that's totally fine. If that's the case, you don't need to have these dot, dot, dots afterwards. All right? So this is the process that we continue over and over and over to come up with our ultimate decimal. Thanks.